Using mathematical induction, prove that for all natural numbers 1 square plus 2 square plus 3 square up to n square is equals to n into n plus 1 into 2n plus 1 by 6. Let S of n be the given statement. 1 square plus 2 square plus 3 square up to n square is equals to n into n plus 1 into 2n plus 1 by 6. The nth term of the given series is given as n square. So in the first step, we will prove that S of n is true on both sides, right hand side and left hand side. So on the left hand side, S of n is given as n square. If we substitute 1 in place of n square, we will get 1 square is equals to 1. So similarly on the right hand side, we have to take the right hand side of the statement n into n plus 1 into 2n plus 1 by 6 and substituting the value of 1 in place of n. So it will be 1 into 1 plus 1 into 2 into 1 plus 1 by 6. So 1 plus 1 is 2 and here 2 into 1 is 2 plus 1 is 3. So numerator can be written as 1 into 2 into 3 by 6. So 1 into 2 into 3 is 6. 6 by 6 is 1. So LHS we got 1 and RHS is also 1. Therefore, S of n is true for n is equals to 1 or S of 1 is true. Now the second step, we have to assume that S of n is true for n is equals to k. So in place of n of the statement, we will substitute k. So that will be 1 square plus 2 square plus 3 square up to k square is equals to k into k plus 1 into 2k plus 1 by 6. So now we have to prove that S of n is true for n is equals to k plus 1. So this statement is for k terms. So we have to add the k plus 1th term on both sides. So since we know that nth term is n square, so kth term is k square and k plus 1th term will be k plus 1 whole square. So adding the k plus 1th term on both sides, which is k plus 1 whole square, we will get the equation 1 square plus 2 square plus 3 square up to k square, and now we are adding k plus 1 whole square on both sides. So we have to take RHS here. So k into k plus 1 into 2k plus 1 by 6 plus k plus 1 whole square. So we can take k plus 1 common because in this term k plus 1 is there, here also k plus 1 is there. So we can write it as k plus 1 into, here what is remained, k into 2k plus 1 by 6 and here k plus 1. Multiplying this k here, k into 2k is 2k square and k into 1 is k, and cross multiplying with 6, that will be 6 into k plus 1. Now resolving this, we will get 2k square plus k plus 6k is 7k. So we can write it as 2k square into 7k plus 6 by 6. Now further simplifying this quadratic expression, 2k square plus 7k plus 6 using factorization method, by splitting the middle term 7k as 4k and 3k, and in the first two terms we can take 2k as common and the last two terms we can take 3 as common. So here k plus 2 is common, we can write it as k plus 2 into 2k plus 3. So we can replace this 2k square plus 7k plus 6 with k plus 2 into 2k plus 3 here. Now we can write this as k plus 1 into k plus 2 into 2k plus 3. Further, we can split this k plus 2 as k plus 1 plus 1 and 2k plus 3 as 2k plus 2 plus 1, and from 2k plus 2 we can take common 2 and write it as k plus 1 into 1. Now comparing this with the equations right hand side, so in place of every n we have k plus 1. So here there is one n and it is k plus 1. So n plus 1, in place of n plus 1 we got k plus 1 plus 1, and in place of 2n plus 1 we have 2 into k plus 1 plus 1. Therefore, by the principle of mathematical induction, the S of n is true for all natural numbers.